Okay, last one we're going to talk about here is the tangent ratio or the tangent function. And again, it's another ratio. The sine compared the opposite side to the hypotenuse. The cosine compared the adjacent side to the hypotenuse. And the tangent compares the opposite side to the adjacent side. So there's no hypotenuse in this case. So whenever we talk about the tangent of an angle in a right triangle, if we're looking at angle C here, we are comparing the length of the opposite side of the triangle to the adjacent side of the triangle. And just like before, I'm going to move this in and out, okay? So right here at 45 degrees, perfect, yeah, that's a nice perfect 45 degrees. I want you to compare the length of the opposite side of the triangle to the adjacent side of the triangle. And maybe you notice something here. Maybe you're looking at this and you're saying, wait a minute, the opposite side has length 4. The adjacent side has length 4. So 4 divided by 4 is 1. And you would be right. So the tangent of 45 degrees is 1. A deeper question, why is it 1? It's because in a 45-degree angle in a right triangle, when I'm looking at 45 degrees, that 45-degree angle, the length of the opposite side is the exact same as the length of the adjacent side. Okay? And it's a ratio, it's a fraction. You're comparing the opposite to the adjacent. So 4 divided by 4 is 1. Boom, there it is. So what's going to happen now when I move this point further away this way? This angle is going to decrease. So something to think about. When I move this point away, what do you think is going to happen to the tangent of that angle? Is this number going to drop above 1? Is it going to drop below 1? Or is it going to rise above 1? Okay? So maybe think about that for a second. Okay? So when I move this point away, the opposite side is going to stay the same length. It's going to stay 4. The adjacent side is going to increase. It's going to get longer, correct? As I move this, I'm going to hide it here. Now, as I'm moving it further away, the opposite side is still 4, but the adjacent side is longer. So when I look at my fraction, opposite divided by adjacent, this opposite side is shorter than the adjacent. So the numerator is smaller than the denominator, so it should be below 1 when we have a fraction, and there it is. So it's about 1/2. So in other words, when the angle works out to be, I know it's a little weird, but when the angle works out to be 26.6 degrees in a right triangle, the tangent of 26.6 degrees is 1/2 because the opposite side is half as long as the adjacent side. Notice again, we're not talking about the hypotenuse. It doesn't come into play. So as I get closer, as that angle gets bigger and bigger and bigger, you're noticing that the opposite side is staying at 4. The numerator is staying at 4 in the fraction, and the adjacent side is getting smaller. So if you think about it, in the fraction you have 4, the opposite side here, divided by smaller and smaller numbers, right? Because that angle is getting more steep. So 4 divided by a smaller and smaller and smaller number, what is happening to that fraction? That fraction, that ratio is getting bigger and bigger and bigger, right? Until we get to that 45-degree angle that we saw earlier. There's 45 degrees. The opposite side is the same length as the adjacent side. They're both 4 in this case. And when I get closer and closer, notice the tangent of that angle is getting bigger and bigger and bigger, right? Because the opposite side is staying at 4, but the adjacent side is getting smaller, right? It's getting smaller. What until we get to what? Look at the tangent here. The tangent's 1.59, right? So I'm going to wait till I get to about 2. So give me a second. So right there, again, this is in a very close approximation. The tangent of 63.4 degrees in a right triangle, that 63.4 degree angle, okay, the tangent is 2. Why? Because the opposite side is 2 times as long. The opposite side is twice as long as the adjacent. And that looks about right. This opposite side is 4. The adjacent is 2. And you're comparing 4 with 2. 4 is 2 times as long as 2. It's twice as long. And I'm going to keep going. What's that tangent going to reach? What's it going to get closer to? Any guesses? Maybe what do you think? What do you think is going to happen when I hit 90 degrees? What do you think is going to happen to that tangent? What's the tangent of 90 degrees going to be? Look at that. At 76 degrees, right? The opposite side is still 4, but the adjacent is 1. Or the opposite side is 4 times larger, 4 times as big as the adjacent side. 4 in comparison to 1 is 4. Remember, it's a ratio. It's a comparison. And I'm going to get closer. Look at that tangent. Look how it's blowing up as I get closer to 90 degrees. Look at that. 84.3 degrees. When it's at 84.3 degrees in a right triangle, when one of those angles is 84.3 degrees, the tangent of that angle, it's 10 because the opposite side is 10 times larger than the adjacent side. The opposite's staying put at 4, it's not moving. But the adjacent is moving, it's getting smaller. And what's going to happen when I get to 90 degrees? What do you think's going to happen? I know it's exciting. You're thrilled, aren't you? Wow, look at that. Wow. Boom. Oh, cool. It even gives me the little infinity symbol, right? Because what's 4 divided by numbers that get closer and closer and closer to 0? As we can see, the fraction is blowing up until we have 90 degrees. And we don't even really have a triangle anymore, do we? Look familiar? Right? That's kind of cool. It says infinity. So what we say is, in math, we don't say infinity. We say undefined. So the tangent of 90 degrees is undefined. And if you try to do that in your calculator, you'll get an error. And the reason you get an error, a deeper question is because you still have an opposite side. It's 4. But the adjacent side is now 0. The length is 0. What's 4 divided by 0? Well, it's not infinity. I mean, that's just the notation it uses here. It's really undefined. Okay, so the tangent of 90 degrees is undefined. Another one that worked out nice and neat, the tangent of 45 degrees is 1. That shows up a lot. So again, we're going to end here. I'm going to, let's put all 3 of these in one here, the sine and cosine, right? Here's the sine of an angle, the cosine of an angle, and 45 degrees. So I'm going to start with a really big angle, right? With a really big angle, the sine is almost 1, the cosine is almost 0. And as that changes, you can see that these numbers change as well. So just remember, the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. If you were to switch into the A&I HL class, you do 3 more ratios. You do the reciprocals of these. They're called secant, cosecant, and cotangent. But for the SL, we just do these 3: sine, cosine, tangent. Okay. And we're going to talk a lot about this. And there's all sorts of patterns going on, and it's really cool. So hopefully this makes sense. Let's come back to class and talk about it as a group. I'm going to give you some problems to work on. I'm going to show you how to use your calculator, and then we'll call it a day. All right?